Good morning. Good to see you. I hope you're glad to see me. I wanted to do a little personal station building today. We're going to do station models. I want you to get your reference table out. I have mine. Let's get our handy dandy reference table. Turn to page 13. We're working with this station model here. This tells you how the station model is explained, and I want to go over it also. So I'm going to give you some data. Here's our data. Air temperature, got a paper and a pen? Our air temperature is 50 degrees. Our dew point temperature, let's move it over. Thank you. Wind direction northeast, wind speed 15 knots. The cloud cover is going to be 50%. Air pressure 996.4 millibars. Alright, so write down your data, our different variables. We have 6 variables here, and we're going to build our weather station with this information. Okay, so first we're going to take our notebook and we're going to build a station together. So let's put a circle. Every weather station model starts with a circle. Alright, so let's say this is Brooklyn, New York. New Utrecht High School is now having a weather station, and we're going to build our weather today at New Utrecht High School. And we're going to start off with our air temperature. So our air temperature is 50 degrees. And where are we going to put that? Okay, top left. Very good. So we're going to put 50 degrees right there. Notice I did not put Fahrenheit. Since this is a station model, we're going to shorten up as much as we can. We want to abbreviate things because when we have our station models on our weather maps, we don't have much space. So we need to abbreviate as much as we can. So we start with our air temperature. It's Fahrenheit degrees, but we do not put Fahrenheit. Next, we have our dew point temperature. Dew point temperature goes where? Okay, down here, 48 degrees. Very good. So we have 2 variables. Air temperature at 50 degrees Fahrenheit, dew point temperature at 48 degrees Fahrenheit, and they're pretty close. So it's probably a very moist situation. Let's see. All right, let's do our wind direction. Wind directions from the northeast. So let's go over our directions first. If our winds are coming from the north, they're coming from up here. Winds coming from the north. Winds are named from where they come from. Down here is the south. The winds are coming from here. They're coming from the west. And if the winds are coming from this side, they're coming from the east. Our winds are coming from the northeast. All right, so we're going to put our shaft line between north and east. All right, the shaft line, it shows you wind direction. Winds, as I said, are always named from where they come from. So after wind direction, we have wind speed. Our wind speed here is going to be 15 knots. Look on your reference table. We're going to look at wind speed. Wind speed, let's look over here, is right down here. Whoops. Right here. We have the shaft here, which is the wind direction. This wind direction is coming from the southwest. And then we have these feathers at the end. We have whole feather and a half a feather. Over here it says whole feather 10 knots, half feather 5 knots, total 15 knots. So we also have 15 knots. So we're going to have 1 whole feather and 1 half a feather. Back to our drawing. Here's our shaft. Doesn't matter which way the feathers go. So we need 10 knots, 1 whole feather, 15 knots, half a feather. Beautiful. I think so. Anyway, so next we have cloud cover. Cloud cover is 50%. When we look at this ball, we can see that this ball can be divided into 4 parts. We usually do cloud cover in quarters. It could be 25%, 50%, 75%, 100% cloud cover. We color in the whole ball. And if it was clear skies and a beautiful day, we'd have nothing inside at all. A clear day would be a clear ball. But here we have cloud cover 50%. So we're going to color in 50% of the ball. And that'll represent 50% cloud cover. All right? The part that I really want to talk about is the air pressure reading. And the air pressure reading is going to go up on the top right side. That's going to be your position for your air pressure. The air pressure we have today is 996.4 millibars. All right, so we need to shorten that up. We need to take a full reading of a barometric pressure and we need to abbreviate it. So we're going to take away first, we take away the units. Then we're going to take away the decimal point. Now we're going to either take away the 9 or a 10, depending on what number is in the front. We call it the 500 rule. If your number is above 500, you're going to have a 9 in front. Here's our 9 in front. Here's our 964, which is greater than 500. So we're going to get rid of this 9 and take that away, which leaves us with 964. We're going to put that 964 right there. That's how we do our conversion. Let me show you the 500 rule. The 500 rule, write this down. The 500 rule, if the reading is over 500, you're going to take or add a 9, like we just did. We took away the 9 to put it on the weather station. All right? Then if the reading is under 500, you're going to add or take away a 10. Let's put that so you can read it. It's so difficult. All right, here we go. All right, so for example, down here, I have a full reading of 996.4 millibars. To abbreviate that on the weather station model, I'm getting rid of the units, I'm getting rid of the decimal point, and I'm getting rid of the 9, which leaves me with 964. That's the number I'm going to put abbreviated onto the station model. No units, no decimal point, got rid of the 9. Let's try another one, okay? So here we have 982.4 millibars. To shorten that up, we get rid of the units, we get rid of the decimal point, and we're going to get rid of that 9 in front. We don't need the 9 in front. We're going to take the abbreviation and put that 824, I call that the root number, and put it by the ball. That's if your reading is above 500. All right? Let's try another one. Let's try another weather station. We're going to do the same weather station that they have in the reference table. Back to the reference table, right here. See? We're going to create this station model from this information. Temperature 28 degrees, dew point 27. Notice their air pressure is 196. 196 is less than 500. So in the 500 rule, if I change that 196, I have to put a 10 in front of it. Notice, it says barometric pressure, 10 in front of it, 1019.6 millibars. So we're going to look at that first. Let's build our station model. Your data is air temperature 28 degrees, dew point temperature 27 degrees, wind directions coming from the southeast, wind speed 15 knots, cloud cover 75%, air pressure 1019.6 millibars, just like the reference table. Let's build it. Start with your ball. Always start with a circle, best you can, all right? The air temperature goes where? All right, 28 degrees. No Fahrenheit. Abbreviated. No units. Excellent. Next, you want to do the dew point temperature. Dew point temperature, 27 degrees Fahrenheit. That's the dew point temperature position. So we're good. We got two variables. The next variable is wind direction. The winds are coming from the southeast, all right? So if they're coming from the southeast, we're down here in the south, right? And this is west, this is east, and we might as well put in our north. All right, so our winds are coming from the southeast. Our shaft's going to go that way. That is representing winds coming from the southeast. The wind speed is 15 knots. 15 knots, one whole feather, one half feather. Let's do it. One whole feather, one half feather. Great. Doesn't matter which way it's pointing. Next, cloud cover. Remember I said we have 4 quarters it could be broken down into. So we have cloud cover 75%. I'm going to make my quarters, and I'm going to fill in 3 quarters. Because you know 3 quarters equals 75%. There you go. One more thing, our air pressure, the conversion, the coding as they call it. So our air pressure is 1019.6 millibars. Right? What am I going to do? First thing, we get rid of units. Good. Next, we need to get rid of the decimal point. We don't need any decimals. And we notice that our root number is less than 500. It's got a 10 in front of it. So we don't need the 10. We just need the root number. So we get rid of our 10 as well. And we take that 196 and we put it up in the barometric pressure reading position. All right, let's practice some pressure readings. Okay, here we go. Here's a couple. The 500 rule. If the number is less than 500, we're going to put a 10 in front of it, decimal before the last number, and the units at the end. The full reading is 1019.6 millibars. Okay. Where did this come from? Next, let me get rid of this. No. Okay, sorry. Okay, the next one, we have 010. 010 is less than 500. So we're going to bring down the 010. We're going to put a 10 in front of it because it's less than 500. Decimal before the last number, and millibars at the end. One more. We have 123. 123 is less than 500. We put a 10 in front of it, decimal before the last number, and millibars is the units. Okay, I have one with the greater than 500 number. Well, we can practice it here. All right, let's practice greater than 500 numbers. So, if I have a weather station and I have 976, that number is greater than 500. What am I going to do? I put 976 here. I put a 9 in front of it, decimal before the last number, and millibar units. That's your full reading. Let's do another one. Greater than 500. Your numbers will never really be near 500. They'll always be in the 900s. Let's say 940. All right? So the number is greater than 500. We bring it down. Greater than 500, 9 in front, decimal before the last number. There you go. One more. Let's do 888. It's greater than 500. Bring it down. Put a 9 in front. Decimal before the last number. All right, you're good to go. We can practice some of these region questions now. All right, see you soon.